Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 9, Graph. A graph G consists of two sets, V and E. Set V is finite, non-empty set of vertices. Set E is a set of pairs. V is vertex, E is pair, and this is also called as edge. Finally, G is equal to V comma E. This is what the graph notation, and you can find different graphs. Those are directed graph, undirected graph, and you can also find other graphs which are weighted graph and non-weighted graph. These are the graphs what we will commonly see in the graph syllabus. And undirected graph, the pair of vertices representing any edge is unordered. That is, U comma V and V comma U represent the same edge because it is undirected graph. That means if I draw a graph, as I don't have any direction, I'll show you the difference. This is what directed graph. 1, 2, 2. Direction is from 1 to 2. It is directed graph. So in the directed graph, 1 comma 2 edge is not equals to 2 comma 1. Whereas in undirected graph, you did not find any direction. So 1 comma 2 represents, which is exactly equivalent to 2 comma 1. These are what directed graph and undirected graph. And the graph can be represented in adjacency matrix and adjacency list. That also we'll see. Before we see adjacency matrix and adjacency list, we'll be showing you some graph. We'll draw some graph. Assume that I have n vertices. N vertices. N is equal to 4. And that's what V, number of V is equal to 4. Now, number of edges. The number of distinct unordered pairs U comma V with U not equal to V in a graph with n vertices is n into n minus 1 by 2. So n is 4, I said 4 into 3 by 2, which is 12 by 2, which is 6. So when you have a vertex 4, you can see edges which are 6 for an unordered pair. Now let's draw that graph and we'll see how 6 edges we'll be going to get. That are 1, 2, 3, 4. 1 to 2, 1 to 3, 2 to 3, 1 to 4, 2 to 4, 3 to 4. Now, how many edges you have? How many vertex you found? 4 vertex. 1, 2, 3, 4 vertex. Edges are 1 edge, 2, 3, 4, 5, 6. So, this is what unordered pairs where U not equals to V. Then calculating edges formula is n into n minus 1 by 2. So, I'll show you one more graph also. The one more graph. You can also see connected graph and you can also see biconnected graph, that is 1 2 2 2 2 3 3 2 4. Now it is what connected graph. So there will be a possibility that I can have not connected graph, that 5 comma 6. Now as 4 to 5 you don't have any edge, this is called as not connected graph. So this is about graphs, and I told you something, that adjacency matrix and adjacency list. So let's see what is adjacency matrix. I think you might have understand this, that if I write V is equal V of G1 vertex in the graph or 1 2 3 4. So you can, the set representation of these graphs are what? E of G1 is equal to 1 comma 2 1 comma 3 1 comma 4 2 comma 3 2 comma 4 and 3 comma 4. Correct? Now so these are what the edges from this vertex 1 2 3 4 5 6. So this is what we were calculated. Now let's see, this is what your edge. How can I frame adjacency matrix from the graph? That part now we will see. Assume that G1 is equal to 0 1 1 1 1 0 1 1 1 1 0 1 1 1 1 0. Now it is looking like a matrix, correct? So in this matrix, if you see, all diagonal elements are 0. So that is what self loop is not there in the graph. So now you can see this one as so we were taken some G is equal to, correct? G is equal to 0 1 1 1 0 1 1 1 1 0 1 1 1 1 0. This is what the graph, and these vertex are one, two, two. You found the edge, right? In the graph we found the edge. That is what G is equal to 1 0 1 1. So that is 1 2 3 4 1 2 3 4. So 1 1 2 1 edge we did not find, so it is 0. 1 2 2, if you find a edge, it is 1. I kept as 0. What does it sense? That I don't have any edge from 1 to 2. If I found any edge from 1 to 3, I used to have 1. So what you can understand out of this is, G is a graph which is represented in adjacency matrix, where 0 is for no edge, 1 is for edge. This is what we have to understand, right? Now 1 to 1 is 0, so 1 to 1 no self loop. 1 to 2 also 0 I kept here, so there is no edge in between 1 to 2. Now 1 2 3, so I wrote here 1, means what? 1 edge is existed. Now 1 to 4, yes, edge is existed. 2 to 1, edge is existed. 2 to 2 0, 2 to 3 edge is existed, and 2 to 4, yes it is. 3 to 4 also yes it is. 3 to 1, so yes it is. Just now we came to know that u comma v and v comma u is same for one undirected graph. So 1 comma 2, if it is having a edge, it is quite possible that 2 comma 1 also have some edge. So I'm going to change this 0 from 1. So finally, what did you understand? You can represent a graph in matrix, and you can also represent a graph in list. That also we'll see how I can do is that will take some head nodes. 1 2 3 4 are head nodes, and this is having a vertex links. Now 1 is having link with what? 1 2 3 4. This is what our base graph, right? We were taken. Now 1 is a head node which is having link to 4, correct? 4, and it is also having a link to 2, and it is having a link to 3. So 1 is a head node. 1 is a head node which is having link to 4th node, and it is having link to 2 node, it is having link to 3 node. Now take again second node. Second node is having link to 3 node and 4 node and 1 node. And the same is applied even for the rest of nodes, head nodes. These are what I am writing as head nodes. These are what the vertex links from the head node. So graph is represented in the form of adjacency matrix and adjacency list. This is about the graph. Thank you all.